the 6 trig functions can all be written based off of the sine and cosine functions. So the other 4, tangent, cotangent, secant, and cosecant, can be written in terms of sine and cosine. So given the sine of and cosines of any angle, the tangent of an angle is equal to the sine of the angle over the cosine of the angle. Okay, this as well as the cotangent equaling cosine of the angle over the sine of the angle. These are called our quotient identities. Okay. As we saw when we were talking about right triangle trigonometry, we know that the secant of an angle is the reciprocal of the cosine of an angle. The cosecant of an angle is the reciprocal of the sine of the angle. So these are called reciprocal identities. So we're able to write our other 4 identities in terms of sine and cosine. For example, equation 220, or example 220, they want to know the tangent of 3 pi fourths. Okay, well I know that's equal to the sine of 3 pi fourths over the cosine of 3 pi fourths. And the way I always think about it, if it's in radians or degrees, is I just draw myself a quick unit circle and figure out where my terminal side is. This is 1/4, 2/4, 3 pi fourths. And then I write down my memorized side lengths, which are square root of 2 over 2, square root of 2 over 2. I identify the coordinates of this point, which would be negative square root of 2 over 2, square root of 2 over 2. Use the fact that the x-coordinate is the cosine, the y-coordinate is the sine. That's going to give me the square root of 2 over 2, all over negative square root of 2 over 2. Any number divided by its negative is negative 1. Okay, the second example, 221. I want to find the secant of 5 pi 6. Well, that is equal to 1 over the cosine of 5 pi 6. Draw myself a quick little unit circle. Figure out that 5 pi 6 is down here. Its reference angle is the pi 6, where my memorized side lengths are going to be 1/2 square root of 3 over 2, and then 1. Identify the coordinates of this point, so it would be negative square root of 3 over 2, and 1/2. So I'm going to take the reciprocal of negative square root of 3 over 2, which is 2, which is negative 2 over the square root of 3, multiply top and bottom by root 3, and I get negative 2 root 3 over 3. Example 22. I want to find the cotangent of 7 pi 6, and that is equal to cosine of 7 pi 6 over the sine of 7 pi 6. Again, draw myself a quick little unit circle. Halfway around is 6 pi 6, so I'm going to go a little bit more. Okay, that gives me this triangle, where that's pi 6, 1/2, square root of 3 over 2. Coordinates for this point are negative square root of 3 over 2, negative 1/2. So my cotangent is negative square root of 3 over 2 over negative 1/2. The 2's cancel, the negatives become a positive, and I get square root of 3 over 1, which is the square root of 3. So I've given you examples on how to use these quotient identities and reciprocal identities. Those are the only 2 quotient identities. What I'm going to do now is write the other 4 reciprocal identities so that you have them available for you. There are 6 of them you need to know. We've already talked about some of them. Third one, the tangent of an angle is the reciprocal of the cotangent. Okay, and then these 3, I can swap the sides. So the cosine of an angle is 1 over the secant of the angle. The sine of the angle is equal to 1 over the cosecant of the angle. And the cotangent of an angle is 1 over the tangent of the angle. So our 2 quotient identities and the 6 reciprocal identities, these 8 identities are on your benchmark test if you're in college algebra, and they will also be tested on the Algebra 2 tests. So that's the first group of identities we have. The next group of identities we have are called the Pythagorean identities. So the next group are called Pythagorean identities. And they are all based off of the unit circle. I take any point P on my unit circle. We know that that point P is at the cosine of an angle, comma, the sine of the angle. That was our definition of our unit circle for sine and cosine. Well, we also know that the unit circle comes from the equation x squared plus y squared equals 1, where this distance is x and this distance is y. So the first Pythagorean identity I have, I replace the x's with cosines and the y's with sines. So the first one is cosine squared theta plus sine squared theta equals 1. I want you to realize that this is a shortcut for writing cosine of theta squared. Okay? What that does is it makes it easier for me to write it without the parentheses. I would have put the squared up here. It would have been if I wrote it like this, that would equal to the cosine of theta squared using order of operations. So to get rid of the ambiguity, they put the squared after the name of the function. Okay? I just want you to realize that that's what that means. So that is our first Pythagorean identity. It gives me a relationship between the cosine and sine of any angle that meets the requirements of my unit circle. Well, to come up with the second Pythagorean identity, I'm going to divide everything here by cosine squared theta, which is a legal mathematical operation. I can divide both sides of an equation by the same thing as long as what I'm dividing by is not 0. That's a key point that you need to understand, that the next identity I get is not valid if cosine is equal to 0. Any number divided by itself is 1. Sine over cosine is tangent, so sine squared over cosine squared is tangent squared. And 1 over cosine is secant, so 1 over cosine squared is secant squared. So that's how I get the second Pythagorean identity. The third Pythagorean identity I am going to get by dividing everything by sine squared theta. Cosine over sine is cotangent. So cosine squared over sine squared is cotangent squared. Any number divided by itself is 1. And 1 over sine squared, 1 over sine is cosecant, so 1 over sine squared is cosecant squared. Okay, so what we now have are our 3 Pythagorean identities. So these are the next 3. Again, you don't necessarily need to memorize the last 2 because you can come up with them the same way that I did. But they should become recognition. That anytime you see a tangent squared and a secant squared, maybe you can rearrange this somehow to make a relationship. Same thing with cosecant and cotangent, cosine squareds and sine squareds. You will see a lot of examples of us dealing with these in later chapters. But how do we deal with them now? We'll do example 23. Example 23 states, say that theta is in quadrant 2 and the sine is 2/3. So 2-23, theta is in quadrant 2 and the sine of theta equals 2/3. I want to know the 5 remaining trig functions. So I want to know cosine of theta, tangent of theta, cosecant of theta, secant of theta, and cotangent of theta. The easiest one to get is the cosecant of theta. By using my reciprocal identity, all I have to do to get cosecant of theta is take the reciprocal of sine, which would be 3/2. Okay, now what I'm going to do is I'm going to use the pieces of information that I have here with a quadrant 2 angle to come up with cosine. So I know, let me erase the board so you can see my work. I know that cosine squared plus sine squared equals 1. Well, I know that cosine squared theta plus, well, I know what sine of theta is. It's 2/3. I know that equals 1. Well, let's solve for theta, cosine of theta. Okay, 2 squared is 4, 3 squared is 9. 9ths for 1 would be 9/9. Okay, move the 4/9 over to the other side. Take the square roots. Okay, square root of 5 is just square root of 5. Square root of 9 is 3. Now, I took positive and negative square roots, but if I go back to my unit circle, I know that I'm in quadrant 2. Okay, all students take calculus. So sine is the only positive one, so my cosine of theta is going to be negative root 5 over 3. And now to get the rest. Tangent is sine over cosine. The 3's cancel, so I get negative 2 over square root of 5. And if I rationalize the denominator, I get negative 2 root 5 over 5. Secant's the reciprocal of cosine. So I get negative 3 over root 5. And if I rationalize the denominator, I get negative 3 root 5 over 5. Cotangent's the reciprocal of tangent. I'm just going to take the reciprocal of this, and I'm going to get negative square root of 5 over 2. So that's how I worked out those examples for 23. We're going to do the same type of work with examples 24 and 25. Okay, 224. It's a quadrant 2 again. I know that the cosine of theta is equal to negative 5/13. So I'm going to use my Pythagorean identity of cosine squared theta plus sine squared theta equals 1. So I have negative 5/13 squared plus sine squared theta equals 1, which is 25 over 169 plus sine squared theta equals 169 over 169. Subtract the 25 169ths from both sides, and I get 144 over 169. Take the square roots. So it's a plus or minus 12/13, but in quadrant 2, I know that sine is positive. Okay, forgot to get rid of the squared symbol. Okay, so my 6 trig functions. Sine of theta is 12/13. Cosine of theta is negative 5/13. Tangent theta, sine over cosine. Denominators are the same, so it's negative 12/5. Cosecant theta, reciprocal of sine, so it's 13/12. Secant of theta, reciprocal of cosine, so it's negative 13/5. Cotangent of theta is the reciprocal of tangent, so it's be negative 5/12. So if I know the quadrant of an angle and I know value of one of its 6 trig functions, I can come up with the values of the other 5 trig functions. So the first 2 examples I did were using the first Pythagorean identity. The next one I'm going to use is I'm going to use the tangent and secant Pythagorean identity. So for example 225, I'm going to use a different Pythagorean identity. The identity I'm going to use is 1 plus tangent squared theta is equal to secant squared theta. Okay? I know what tangent of theta is, so I can use that to find out what secant of theta is. That was the directions of 225. It gave you quadrant 3, tangent is 7/5, and it wants the other trig functions. Okay? I'm going to show you 2 different ways to do it. The first way is using trigonometric identities, and the second way is solving this right triangle. Okay? So first thing I do is I have my identity. So that's 1 plus 7/5 squared is equal to secant squared. Okay, this is 49/25. So that's 74. Is secant squared theta. Okay, I'm in quadrant 3, so tangent. So tangent's the only positive, so tangent and cotangent are positive. Secant's going to be negative. So I'm going to take the negative root, so secant of theta is equal to negative root 74 over 5. Okay, from that, from this one I can get cotangent, from this one I can get cosine. So cotangent of theta is the reciprocal of tangent of theta, which would be 5/7. And then cosine of theta is the reciprocal of secant of theta, so it's going to be it's going to be negative 5 over root 74, which is negative 5 root 74 over 74. So that just leaves me with sine and cosecant, okay? I can use the cotangent cosecant identity or the sine and cosine identity. I'm going to use the sine and cosine identity. So I know sine squared theta plus cosine squared theta is equal to 1. I'm looking for sine. of theta, cosine of theta, I'm going to write it as the first way, which is -5 over the square root of 74 squared is 1. So sine squared theta is equal to 25 plus 25 over 74 is equal to 1. So that's 74 over 74. If I subtract 25 from 74, I'm going to get 49. If I take the square roots, okay, again, sine in quadrant 3 is negative, so I'm going to take the negative root. Okay, rationalizing. I get -7 root 74 over 74. Okay, and then the cosecant of that is the reciprocal of this. And that gives me negative root 74 over 7. So that's how I can solve this using Pythagorean identities. Okay? And just remember, Pythagorean identities came from the Pythagorean theorem. X squared plus y squared equaled 1 on this unit circle. So I'm going to do these a second way, and we're going to get the exact same answers just by thinking about it. Okay? So the second way I'm going to do this is I'm just going to draw myself a triangle that has a tangent of 7/5. Okay? And then I'm going to use the quadrant 3 information to tell me whether things are positive or negative. Okay? I just draw any old triangle, label theta. Tangent is opposite over adjacent. Okay? I've got my two sides. Let's find the third one. Okay? It's going to be 7 squared plus 5 squared, so it's 49 plus 20. So this is the square root of 7 squared plus 5 squared, which is the square root of 74. Okay, then I'm going to use just my basic identities. And then I'm going to use the correct sign based off of which quadrant I'm in. Okay, again, tangent and cotangent are positive, everything else are negative. And I'm just going to write down the ratios based off of this right triangle. Okay, sine is opposite over hypotenuse. 7 over root 74. Okay, I'm not going to rationalize it, because if you go back in your notes, you'll get the exact same answer. Cosecant's the reciprocal, so it's root 74 over 7. Cosine's adjacent over hypotenuse, so it's 5 over root 74 with the negative sign. Reciprocal is negative root 74 over 5. Tangent's opposite over adjacent. And cotangent is adjacent over opposite, or the reciprocal of tangent. Okay? Now, one thing I want to warn you about is I'm not using the unit circle, but I'm using the Pythagorean theorem to come up with these, but you do need to understand the relationship from the unit circle to get the correct SIG and signs on these. Okay, if I wanted to know where these points were on the unit circle, well, it's easy. We know the point on the unit circle is going to have the cosine of theta as its x-coordinate and the sine of theta for its y-coordinate. So the x-coordinate would be -5 over root 74, and the y-coordinate would be -7 over root 74. And again, these can be rationalized to come up with -5 root 74 over 74 and -7 root 74 over 74, like I showed you the first time I did the example.